Suppose you create a large number of atoms. Suppose you make plutonium, and you have this plutonium here, and you wait. And after about 24,000 years, half of the plutonium would have exploded. And you have this half left. So is it now the old man? Is it something with not much life left? So you make some new plutonium, and you compare it to the old plutonium. And they behave identically. This one isn't aged. In another 24,000 years, half of it will decay, half of this will decay. And you take the part that's left, 1/4 of the original. And it behaves like brand new plutonium. This stuff doesn't age. So what is going on here? The fact is, what's going on here is so mysterious that we just think of it as a new law of physics. It's not something you explain in terms of other things. There's no mechanism inside that's click, tick, 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 ticking. Suppose you create a large number of atoms. Suppose you make plutonium, and you have this plutonium here, and you wait. And after about 24,000 years, half of the plutonium would have exploded. And you have this half left. So is it?
Good evening, and welcome to Environmental Coffeehouse. I am your host, Sandy Shellis, and this is my guest, Paul Mobley. Welcome, Paul. I am thrilled to have you after all of this time. We have been
Thank you for
writing
having
back
me.
and forth. Yeah. Well, you've got something we need and to learn. We had Carl Paul on, who from the eco what is it they call themselves?
I think it's something with Seattle, isn't it?
Yeah, well, that his name is Soyaddle, but he is the all of a sudden I had a brain fart. The the nuclear people that think
Right.
nuclear power will save the planet, and
Right.
eco-modernists. Thank you, Nadia. Well, and but tonight you are here to give us a slideshow. I've got everything ready, and so take it away, Paul, and then I'll
Well,
say hi to everybody.
I've been researching all this for quite a few years now. Like I said, I was a civil engineer in the Air Force, operating engineer in the private sector, and after Fukushima happened, I pretty much dug in real deep and tried to get some of this information known and try to at least spread it around and get people this knowledge, So I thought we would start with a little bit of the basics.
Give us the basics.
So sure. So if we want to start with number one, we can go with the typical atom, what an atom looks like.
All right, guys, we have a slideshow coming. All righty.
So you got your protons and neutrons in the middle there with the nucleus, and then you have your electron. This is kind of a poor representation as it doesn't really orbit around the nucleus. It's more of like a cloud of probability. So this is basically our first understanding of quantum mechanics, is this probability. And so if we can understand the basic structure of an atom, and we try to understand what radiation does to atoms, is basically it either attracts or repels an electron away from its orbital, or it causes some sort of scattering effect, which is what like gamma does through electromagnetic radiation. We can probably move on to the next one there.
All right, here we go.
The difference between radioactivity and radiation. Radioactivity is the parent isotope or nuclide, and then what it decays into is the actual radiation. That's your alpha, your beta, your gamma, X-ray, all that. it's important that we differentiate between these two because there is a difference. And a lot of people pretty much take these as being the same, and they just aren't. So that's very important to know. When trying to read all this stuff on what they mean, you have to know this terminology. Otherwise, you could get it wrong. So alpha is basically the nucleus that comes out, and it's exactly like a helium nucleus without the electrons. 2 protons, 2 neutrons. Okay, the beta is an electron. That's the electron that is emitted out, and then gamma is your electromagnetic waves. It's a ray. It's just pure energy. Alpha and beta are actual particles. They're something. It's not just pure energy. Okay. We could probably move on to the next one from here.
Okay.
So what radiation does is it takes the electron from the orbital. Okay, and this represents the way that alpha does it. Alpha, since it is positively charged, it will attract an electron from its orbital, and that's the damage that it does. That's what radiation damage does. Is it takes electrons and it causes things to become unbalanced, unstable, and that's where the damage comes from.
Wow.
So
Wow.
beta is negatively charged. It's an electron, so it will repel it. It will push it out of its orbital, where alpha attracts it out of its orbital, and that's what ionizing means. Is it causes it to be an ion, an unbalanced. It doesn't have the same amount of protons as electrons
Okay.
at that point.
All right. We're
Okay,
getting a
so
lesson for sure.
okay. So when we talk about gamma, we can probably move on to the next slide. It's a bit different. Okay. This is colliding radiation. This happens through kinetic energy from it actually hitting the electron. And this is mainly through Compton scattering. There's Rayleigh scattering. There's the photoelectric effect. And these are all just ways that gamma can affect an electron of an atom. And you can see secondary ionization can occur. As it hits one electron in one atom, it can bounce off and strike another electron in another atom. So that's how gamma radiation works. It's all affecting the electrons of the atoms.
It's pretty cool.
Yeah. So what is the next slide? Is it the penetration, I think? Yeah. So alpha can be blocked by a sheet of paper because it's the bigger particle. Beta can kind of go through your skin, and it could be kind of blocked by a thin metal. Gamma pretty much goes through most things, even lead it can go through, and then neutrons just go through everything. The energy is distributed along however long path it is. So they say that gamma can travel up to 10 feet in the air.
Mm-hmm.
So it's going to deposit all of its energy through that 10 feet. Okay. Now alpha, it only travels millimeters in the air, but it deposits its energy within those millimeters.
So alpha is blocked by clothes or even the skin?
It's blocked by paper, by a piece of paper. Yes.
Oh, interesting. Okay.
Right.
Okay.
Right. Even by a piece of paper.
Hmm.
Right. They just don't. It doesn't travel as far.
Thank you.